Okay, everybody. Find a computer.
Hey, you found laptop.
Yay, okay. Oh,
Seeing a
pants.
sunny event.
Those are pants.
See a mountain tent?
Oh, I only found the laptop. If you want to know how to make a game like the Emoji Scavenger Hunt, I'm going to show you how to do that in this video. Hello! In this video, I am going to show you how to classify an image or images in real time from a camera in JavaScript in the browser with P5.js and ML5.js. In a minute, I'm going to start explaining stuff and actually writing some code. And if you want to skip to that part, just check the time codes and you can go right ahead. But before I get there, let me explain something. This video that you're watching is essentially a remake of a video I made in 2018 called Image Classification with MobileNet, and it's part of a beginner's guide to machine learning in JavaScript. I am remaking a bunch of these videos because just this past summer, ML5 1.0 was released. There is a new version of the library. There is a brand new website, new documentation, new examples. So I'm here to do those tutorials again. But if you happen to be inside of the larger playlist of ML5 videos, just be aware, some of them were recorded many years ago, some of them are new. It's very easy to tell. Just look at how much gray hair I have, and be aware, if you're watching one of the older ones, check the ML5 website. Maybe some of the examples that I'm presenting in those older videos have changed. I'll also mention that this video sits inside of a syllabus called Introduction to Machine Learning for the Arts. It's part of a course that I'm teaching at the IMA program at Tisch School of the Arts, NYU. The reason I mention this is that many courses in machine learning might start with the lower level details about how neural networks work. For me, I'm actually going to go in the reverse direction inside of this playlist. I'm starting with an application of machine learning, image classification, and slowly over time in future videos, I will peel back the layers and look at how things work in more detail. But let's take a look at this from a high level. I'm going to start with a pre-trained machine learning model. This particular model that I'm going to demonstrate to you is called MobileNet. It was created with a process known as supervised learning. In order to train a machine learning model with supervised learning, you need a data set, a labeled data set. I can't draw a dog, apparently. Sorry about that. This data set is then used to train the model. So if we start with a blank model, probably some kind of neural network, and then each one of these images is sent in as the input to the model. The model is then going to make a guess as to what it thinks is in the image. That is the output. This is a supervised learning process because we actually already know what the correct answer is, cat. We're waiting to see if the model guesses cat correctly. If it does, great, we can move on and go to the next image. If it does not, if it gets it wrong, then the model needs to be adjusted so that hopefully the next time it's going to be more likely to get the correct label for this image of cat. The data set is processed through the model many, many times. The model is making changes to try to have the fewest number of errors. After that process is finished, all of the settings for the model are saved, and that's in fact what I'm going to load in the P5.js sketch itself. The trained version of the model that was trained on some data set that then we can pass new images in and see what it guesses is the correct label for that particular image. This begs the question, I said we're using a pre-trained model. The model was trained with the supervised learning process, and the model we're actually using is called MobileNet. What data was used to train MobileNet? Who made MobileNet? The data set that was used to train MobileNet is called ImageNet, and this is a project that dates all the way back to 2006. It is a foundational data set in machine learning. The ImageNet project was spearheaded by renowned researcher Fei Li, and it began when she met researchers developing WordNet, a lexical database of words, which is a well-known project out of Princeton that I've used in all sorts of other videos about natural language processing. If you want to learn more about how ImageNet was created, I would encourage you to watch Fei Li's TED Talk, How We Teach Computers to Understand Pictures. ImageNet itself has over 14 million images across over 20,000 categories. Now, if you've watched any of my videos, you've probably heard me talk about the concept of bias in machine learning. What does it mean for a machine learning model to have bias? In 2021, Kate Crawford and Trevor Paglen published Excavating AI, the Politics of Images in Machine Learning Training Sets. They did a deep dive into the ImageNet database with a focus on the problematic labeling practices found in the person category that reflected many biases and perpetuated many stereotypes. I really encourage you to read over this article and look at this research. Now, MobileNet, the model that I'm about to use, was not actually trained with the full data set from ImageNet. In fact, it was trained with a particular subset. This subset is known as the ImageNet Large-Scale Visual Recognition Challenge, which was a essentially research challenge project to test different kinds of image classification algorithms and techniques that ran between 2012 and 2017. Let's take a look at MobileNet in action. I've got one of the P5 examples. Again, I'm gonna slowly, step-by-step, go through how to write the code in a minute, but let's just try classifying a few images. So here we go. We have an image of a house finch, and perfect. It says it's a house finch. I've got an image of a goldfish, and perfect. It says it's a goldfish. Look at that. Confidence of 90%. Here is an image of a French bulldog. Perfect. It's a French bulldog. Let's see, let's get a little bit harder. Here's an image of me with my dog, Gloria Pickle, who is not a Labrador Retriever, so that is incorrect. As well as, here an image of a puffin. Let's see what we get here. King penguin. That is not a king penguin at all. That is a puffin. Why does it know with some degree of certainty and accuracy that this is a house finch, but when I show it a puffin, it gets it completely wrong and has a very low confidence score? So first, I should reveal something to you. I went to this GitHub repo, which includes a gallery of sample images from ImageNet. And look at that image of the goldfish. And if I keep scrolling down here, oh, there's that house finch. So certainly, if I take an image that was in the training data set and I pass it in to the model, it's going to most likely get it correct. But even if I were to look for a different image of a house finch, it labeled it correctly. Now, actually, I just downloaded an image of a house finch from Wikipedia, so there's probably a good chance that image is also in the data set. But this is not the point that I'm trying to make. The point that I'm trying to make is this particular list of 1,000 classes is totally arbitrary, and it's not particularly useful, in fact. It was made for the purpose of researchers competing to build a model that would work better. If you want to classify images according to your own labels without having to build your own data set of millions of images, there is a way to do that. It's called transfer learning. I have other videos that I cover that in more detail. In particular, I use a tool called Teachable Machine, and I will show you, I'll try to, at the end of this video, come back and show you a bit more about that as well. Ultimately, this is why it cannot recognize this image as a puffin. There is no puffin label inside of that limited selection of 1,000 classes. So you might be wondering, why is this thing called MobileNet? And why is MobileNet the model that is inside of ML5 as your hello world, our first default option for doing image classification? So the name MobileNet literally comes from, could we make one of these image classifications run on a mobile phone? So there is this question of trade-offs whenever you're working with training a machine learning model. How big is the model? How many parameters, how many weights, how many dials are inside of that thing? A bigger model might be more accurate, more so-called powerful, but it might be slower to run or require larger, more powerful computers. So the researchers who developed MobileNet, their goal was to create an optimized, efficient image classifier that could run on a mobile device. You can read all about their work in the original paper that was published in 2017, as well as in the GitHub repository. This particular model, or the version that we're using, is a TensorFlow.js model. Okay, it's time. Maybe you just skipped to this point, which would totally be understandable, but I am now going to look at the ml5.js website, and we're going to see how do you write the code to do image classification with P5.js right there in the P5 web editor. I'm going to click over to the reference. You can see a list of models here that are supported by ML5 at some point, maybe even depending on when you're watching this, I'll have videos on all of these. But today I'm looking at the image classifier, so I'm going to click over here. So the first thing that I need to do for anything that I'm going to work on with ML5 is make sure I have the library imported and in fact the correct version of the library. I have a totally empty P5.js sketch in the web editor right here. I'm going to go to index.html and I'm going to see here that the only two libraries that are imported are the P5 library and the P5 sound library. I don't actually need the P5 sound library, so I'm going to remove it. And then I'm going to go here, copy this script tag and paste it in. The most important thing is the @1, which says I want to use the 1.0 version of ML5, which is the whole reason I'm here today making this video. For every model in the ML5.js library, the first thing I need to do is create a variable that's going to hold the model itself. I'm going to call that variable classifier. The next step is to actually load the model. Easiest way to do that with P5 is to use the preload function. You'll notice that I'm calling a function called image classifier. This is what's known as a factory function, it's kind of a fancy name for creating the image classifier object, and it is namespaced under the keyword, the name of the library itself, ML5. Then I want to load the MobileNet model. That's the default model, the demonstration model that I'm going to show you. There are other models that you could load. You could even train your own model. I alluded to this earlier with a process known as transfer learning in Teachable Machine. I'll come back to that later in the video. And in those cases, you might be putting a URL path to a model or a name of a different model there inside of quotes as a string. Now, let's take a minute. I'm really good at making these videos way too long, but I think this is important. Let's talk about where the model is actually coming from and where it's stored. We have a laptop. Inside that laptop is a browser. Inside that browser is a P5 sketch. There is a server out in the world, probably owned by Google, that has the files for the MobileNet model. When from P5, you call the image classifier function with the MobileNet string, the code reaches out to that web server and gets the files for the MobileNet model and downloads them into memory inside the web browser. The reason why I'm stopping here to harp on this is because I want to emphasize that while your P5 sketch is running on the internet and making calls to servers like the one hosting the MobileNet model files, when the image classification process occurs, which is what I'm about to code next, it actually happens here locally in the browser itself. So if you take a picture of yourself, for example, with your webcam, and that is loaded into your P5 sketch, that image is kept private on your computer. It is not sent anywhere else. This is very important because there are other kinds of machine learning systems that require you to process the image on a server. If that's the case, there is a loss of privacy here. So all of the models inside of ML5 run in the browser itself. Now, again, there's lots of other things at play here. There's the P5 web editor, there's your internet connection and the network you're on, but it is important to note that this is an on-device model, meaning the model actually runs with your own computer's CPU or GPU locally on your computer in the browser, if you have your mobile phone, on the mobile phone. So I'm talking about this too much, but this is something you really want to think about whenever you are building your own software or using somebody else's software that runs a machine learning model. The data that is being sent as input into the model, where is that happening? On your device or on somebody else's server somewhere? Who has access to that data? Now we need an image. Earlier, when I was demonstrating the model, I had a P5 example that you could drag and drop an image into. I'll make sure to include the code for that one as well. But for this one, I'm just going to load a local file. I'm going to upload a file. Let's just use the image of me and Gloria just to see what happens. I'm going to load that image with preload. Let's draw that image into Canvas. Oh, I should not have called it image. What a terrible idea. The keyword image is a function in P5. So I'm going to just call this image IMG. Now, I didn't resize the image to make it smaller. So let's draw the image the size of the canvas. There we go. So now I've loaded the image classification model and the image. How do I send the image into the classifier model and get the results? It's right there in the step-by-step tutorial in the ml5js.org documentation. Classifier.classify the image. This is the function call. I want the classifier to classify the image. However, this is asynchronous, meaning it takes some time to process the image and get the results back. So I need to read the results in what's known as a callback function. The first argument to the classify function is the image that I want to classify. The second argument is the name of the function. I get to make up that name. I can call it anything I want, where the results will be delivered. As long as I use the same name, it will match up. That callback function needs to have an argument. I'm calling that argument results. Again, I can name that whatever I want. That is a variable that will be filled with the results of the model. Let's take a look at that. What did I get here? I'm console logging results. I can see that results is an array. Why is it an array? Shouldn't it just be Labrador Retriever, one thing, a string? What the MobileNet model returns is actually a list of possible labels, all with a confidence score. And ML5 behind the scenes is sorting that list according to the label with the highest confidence score, Labrador Retriever. We can see what is the second highest, Beagle. So that's good, actually. Gloria is actually a Beagle mix. Gloria is a Corgi Beagle mix. Could we get a Corgi as the third one? Eskimo Dog Husky, no. And in fact, if I wanted to see more labels, I could add a third argument here. For example, I could actually see all 1,000. Now I have a list of all 1,000 possibilities. And we could scroll all the way down to the bottom and look at what is the very last one, a Persian cat. Look at that low confidence score. Gloria is not a Persian cat. The model is always producing all of that data. The ML5 function is just choosing how much to show to you. So in this case, if I just wanted the top one, I could just change this to 1 and I've got one thing, although it's still in an array. Now, all that I've done here is log the array to the console. What if what I want to do is use that label for some purpose? Well, I could create a global variable. I'll call it label. Then in order for me to get the label, and let's go back to the default with 3 things, we have to know a little bit about how arrays and objects work. So if that's new to you, I'll refer you to my other videos on arrays and objects and JSON and all that kind of stuff. But basically we can see there are 3 things. So I know what I want. The label is in the results array in the first element 0. And then In the 0 element, there are two properties, a label and a confidence. So I could say results.label. So now I've taken the first element in the results array, the label property, and stored that in a separate variable, which means I could now do anything I want. I could have an if statement to say, if the label is this, do that. Or in this case, I could just draw the label onto the canvas. All this extra code is just to draw a black rectangle with white text on top to make it as visually prominent as possible. I'm getting this kind of funny error down here, which I didn't understand why that was happening. And now I realize it has to do with the asynchronous nature of the classification process. So when I first create this label variable, it's undefined. P5 gets to draw before got results happen. So for a couple frames, it's trying to draw the text undefined, and it doesn't know how to do that. So I probably should give it like an initial value, like waiting. I don't know, could you see it? If we slow this down, you could see that it wrote waiting on the screen very quickly before it wrote Labrador Retriever. Maybe as an exercise, could you take this exact sketch, think about how you're drawing the text in a more thoughtful way? Maybe you put it at the bottom, maybe you use some transparency, maybe you also draw the confidence score in the canvas. Could you change the color, maybe tint the image according to the confidence of the label? All sorts of creative possibilities there. Now, if you recall the emoji scavenger hunt that I played at the beginning of this video, that classified images continuously in real time based off of a feed from the webcam on this laptop. So let's look at how I would adapt this particular code example from loading a static image to continuously classifying a webcam feed. I'm going to duplicate the sketch. So both examples will be part of the materials for this video. And I'm going to replace the image variable with a video. And instead of in preload saying image equals load image, I'm going to take this out. And in setup, I'm going to say video equals create capture, which is the P5 function for opening a media element that gets a continuous real-time feed from the default camera. So we immediately see at the bottom here this extra rectangle that is the actual real-time feed from my camera. I'm going to draw the video to the canvas, and I'm going to classify the video. So you can see it got spotlight. That's what it thinks it sees. If I hold up this Rubik's Cube, for example, nothing's changing though. So even though this is working, what it's doing is classifying the video only once during setup. One of the beautiful things about the 1.0 version of the ML5 library is every single function of the models can be called a single one-time way. That's what you're seeing here, classify, or a continuous way. And in fact, I can just say classify start. And now, if I say classify start, it really just wants to classify this as a shower curtain. Look, can we get it to recognize like a pen, hairspray, microphone, syringe? Let me clean up a few things here. I can actually hide the video. So I'm only seeing it in the canvas. I'm going to just change my canvas size to be friendlier to the video aspect ratio. And I'm going to fix up how I'm drawing the actual label itself. And there we go. I present to you your theater curtain and your train whistle. It's a balance beam. Once again, we can see the issues around having just this limited set of 1,000 classes that are in the MobileNet library. Now you could imagine, how would you build your own emoji scavenger hunt? For example, what if I were to say, if label equals shower curtain, then let's draw a background that's green with a little bit of alpha. And hopefully, as I step to the side, come on, give me a shower curtain. There we go, we can see, I guess because the screen is green, it's hard to tell. But you get the idea. This is the kind of starting point from which you could build your own creative application. Another model you could try is called DoodleNet. This was trained by ITP researcher Yining Shi, who used the QuickDraw dataset. And with this particular model, you could actually classify drawings that you make on the canvas with the mouse. I also mentioned how you could use Teachable Machine to train your own model with a process known as transfer learning. Now, I covered transfer learning in great detail in other videos. Let me give you a quick speed through of just getting that to work quickly in this particular example. I'm going to go to the Teachable Machine website. I'm going to click Get Started. I'm going to click on Image Project. I'm going to make an image model with my webcam, and I'm going to click here and I'm going to say train whistle. So I'm going to step out of frame and I'm going to show the camera the train whistle. I'm going to click hold to record, and I'm going to create a lot of images of the train whistle, or at least me holding the train whistle from different angles. Now I'm going to try to get this Rubik's Cube, and I'm going to click webcam, and I'm going to show a lot of images of this particular Rubik's Cube to the camera. Trying to do over 100 images each. I'm going to add one more class. I'm just going to call it Dan, and I'm going to hold to record and make lots of like silly faces in front of the camera. Okay, great. I'm now going to click Train Model, and this is going to take all of these images and train my own model built on top of MobileNet, but using only these 3 new labels. I can actually see right here, just test it. It sees that it's me, Dan. It sees that this is a train whistle, and this is the Rubik's Cube. And I can click over to Export Model. I'm going to click Upload Model. I'm going to click Copy for this model's URL. Then I'm going to go over to the sketch, and instead of the MobileNet keyword in a string, I can actually now paste the URL to that Teachable Machine model, and look at this. Dan, Rubik's Cube, train whistle. Right there, it just didn't matter. Look, I saved this to the end. You're very lucky if you actually watch this video all the way to the end, because this is the most interesting application of this particular image classification technique inside of ml5.js. And right here, I could do things like say, hey, when you see the train whistle, let's cover the background with a pinkish hue. So, emoji scavenger hunt, find the train whistle. There we go, it found the train whistle. There's several important things that I should talk about before I wrap this up. Number one, the model here on Teachable Machine is actually trained with a mirrored image. So if I raise my right hand, you can see it's actually on the right of me on the screen. But if I go to my particular P5 sketch, it's not mirrored. One of the wonderful things about using the newest P5 and the newest ML5 is I can actually add a property, and I need to do it both for the image classifier and the video itself that tells P5 to flip the video. And this is actually good for just making the interaction more intuitive, as well as matching the actual training data that was used to train this model, which could matter in some circumstances. To do that, under Create Capture, I'm going to add a property, flipped is true. Now you can see it's flipped, but that property is added inside of curly brackets. This is a JavaScript object literal, and this is the kind of thing that you're going to see more and more of in other ML5 models and functions when you want to modify the way that the model is loaded or works. Different properties and parameters can be set with a JavaScript object. But I only did that for Create Capture. I also have to add this same exact JavaScript object to the image classifier model. I'm going to press enter, and you can see the ML5 image classifier is both loading this model and making sure it reads the image data flipped. It's a little bit redundant that you have to do it for both, but it has to do with the way that P5 is actually just changing the way the image is drawn, not actually manipulating the underlying pixel data. So we've got to tell ML5 to also do the same. I should also pause here and mention that this training of the model happened all here inside my web browser locally on device. So none of these images that I took from my webcam went to any server, and the training process of the model happened here locally. Once I clicked Export Model, then the model files itself got uploaded to a Teachable Machine server so that I could access them later. But I didn't have to do that. I could have downloaded it. This also does integrate with Google Drive. So I could save this project and then my images would be saved on Google Drive. But this is, again, I'm just recapping here, one of the reasons why I like working with on-device models. If you're careful and thoughtful about it, you do have the ability to keep all of your data private. Lots of other systems would require you to upload your images to a server in order for some model to be trained. The other thing I should mention is this is not some sort of perfect system. Like, which thing is it? Is it me or is it the train whistle? Well, it's kind of like going back and forth and getting a little confused. That's because I only showed the model the train whistle without me in the frame. And I only showed the model myself without holding the train whistle. Same thing for the Rubik's Cube. I mean, what happens when I hold these both up? Like, well, maybe this one's more prominent, et cetera, et cetera. I should also say that this isn't some magic intelligent system that now really understands what it means to be a train whistle or what it means to be Dan or a Rubik's Cube. It's just learned the pattern in the pixels that I presented to it. And it's learned just as much about me holding the Rubik's Cube with my hand as it has learned about the Rubik's Cube itself, as well as the background. So I don't know if this is gonna work, but I'm gonna like turn, you're gonna see a little bit more of my studio here, some of the old remnants of the Apple II Plus. There's a little window to the outside world of the Hudson Valley, and you can see it's still kind of getting it right. But is it gonna get this? Yeah, so, the back, it's able to, no, now it thinks this is the train whistle. You can see it's not able to get the Rubik's Cube anymore because so much of how it learned about what the Rubik's Cube is has to do with its relationship, to the background. All right, I think that's kind of the end here of this particular video. So poke around on the Coding Train website. There's many more videos in this series. I'm sure YouTube will recommend some to you that are maybe related. Let me know what questions you have in the comments. You can also join the Coding Train Discord and ask there. Let me know what you think, and I'll see you next time on the Coding Train.